going to start our discussion on cannabis, or THC, first by looking at the mechanism of action of cannabis. So you can see that this gets a little bit complicated, but what I want you to focus in on is when an individual is taking THC or some other alternative drugs, they're activating these CB1 receptors. And so we'll talk about what these CB1 receptors do normally, and then what THC does. And so first, we have endogenous cannabinoids. So those are actually made in the postsynaptic terminal, so a little bit different than some of the things we've been talking about before. But the endogenous cannabinoids, anandamide and 2-AG, which you can see here, the green star and the green little, whatever that thing is. So those are going to get made, and they're going to diffuse across the membrane. They're going to bind these CB1 receptors, and they're going to do a few different things. So after they're made, they diffuse back to that presynaptic terminal, and they're going to bind and activate the CB1 receptors, which we mentioned, but noting that those CB1 receptors are G protein coupled receptors. You can see they have the classic G protein 7 transmembrane domain structure. And then, if it's a G protein coupled receptor, that is coupled to a G protein. And so these little dots in here are G proteins that they are coupled to, and those are going to go and do or have some specific actions. And hopefully what you can see from this one is that they can go and they can inhibit the calcium signaling, so less calcium inside the cell. This one, I think the people who drew this, they just got it wrong, because I was like, that doesn't make any sense. If you're increasing potassium, that would depolarize the cell. But this action actually hyperpolarizes the cell, and I think the confusion is that these potassium channels, potassium can go in or out depending on the different type of activation. So if you have your diagram, you're going to want to put this arrow out, because when we come down here a little bit, when I show you that activity, it's the opposite of what they have here. But I did look it up, and it makes more sense if it is increasing the efflux or the outflow of that potassium. And another thing that the internal the activation of those G proteins can do is we're going to decrease the formation of cyclic AMP. And some of you may be familiar with cyclic AMP as a second messenger in some of your other classes, but basically it's going to decrease overall activity inside the cell. As activation of cyclic AMP does a bunch of different things. One thing it does is activates protein kinase A to then go activate a whole bunch of intracellular signaling stuff. So it's acting by causing this inhibition or decreasing that formation of the cyclic AMP. And then here's the one thing that it's doing. So it is opening inwardly rectifying potassium channels. That's causing the potassium channel to leave. So this is the arrow that you need to change. It causes potassium to leave the cell. That is going to hyperpolarize the presynaptic terminal, make it less likely to release the neurotransmitter. And I want to highlight again, so that's it doing here. You're causing the potassium to leave, so you are preventing the release of neurotransmitter. And then also on this side, you are blocking those voltage-gated calcium channels, so you're preventing calcium from coming in. So again, preventing release of that neurotransmitter. And that is just written down here. So the closing of those calcium channels, preventing that neurotransmitter release. And then the anandamide and 2-AG, those endogenous cannabinoids that are naturally going to bind to the CB1 receptors, are either taken back into the pre or the postsynaptic terminals, so recycled. And then, now, this whole signaling is automatically going to do that. We're going to inhibit most of the neurotransmitter release. And then, if you see what THC does, it just binds and activates those same receptors. So it's doing the same thing as those endogenous cannabinoids, but now there's greater activity of those CB1 receptors because now you've added something extra. So all THC does is bind and activate those CB1 receptors. And looking at the second objective, which is to map the neuroanatomical distribution of CB1 receptors in the brain and then look at the effects of when THC is acting on these areas. This is a pretty nice image, and it kind of shows you the overall distribution of the CB1 receptors in the brain. You can see that they are located in the hippocampus, in the amygdala, and then also in these red regions here. These are the caudate and the putamen, which are the basal ganglia that you'll see. And you can also see there's quite a few in the cortical areas as well. So pretty widespread, but more localized in some areas than in others. And one thing that is interesting is that these CB1 receptors change during development with, they believe, more expression of CB1 receptors during adolescence. So during teenage years, when the drive is to focus on what those individuals are doing and to kind of, I don't want to say like shut out the rest of the world, but it's one of the reasons that there is that difference in processing during adolescence. And I always think of it as, oh, it makes sense why teenagers seem like they're high. And so if you think about the presence of these receptors in multiple regions of the brain, then you can recognize that THC is going to have a wide range of effects. So if we look at some of these specifically, coming down here, the amygdala, normally important in emotion, fear, and anxiety. With the use of THC, it can lead to panic or paranoia. The basal ganglia, normally involved in motor control, planning or starting a movement, often pattern behavior or habit behavior, and for THC use, that can slow overall reaction time, and also the perception of time. And then in the brainstem, connecting information between brain and spinal cord, that is probably why THC has anti-nausea effects, right? So you can see like some bad effects, some good effects. There is expression in the cerebellum, which is normally important for motor and balance. And so if you are affecting or inhibiting something that's important for motor and balance, you're probably going to have some impaired coordination. Then the hippocampus, so this blue structure right here, normally important for learning and memory. And so THC often does impair memory formations, and especially after long-term use. And then, so the hypothalamus, involved in eating, sexual behavior, regulation of the fight-flight response. One of the things that they've seen is that the increased activity with THC there is one of the things that increases appetite. And then, so the cortex, spanning multiple different regions, if you are going to inhibit activity there, you're going to have altered thinking, judgment, and sensation. And then there is also activity in the nucleus accumbens, which is normally involved in motivation and reward, which is what leads to euphoria or feeling good. And in the spinal cord, activity there, again, transmission of information between the body and the brain, and that is where pain is often processed. And so, which is why THC is often used for a pain management. So multiple regions of the brain have those CB1 receptors, which is why THC has a multitude of different effects. And if we look at some of the acute versus long-term effects of cannabis or THC use, one of the things is that it is not toxic. So there is, like, the acute toxicity is very low. So no known cases of death from overdose. And it's just not doing the same thing as like opiates are doing, where you are inhibiting the movement of the diaphragm. So lower presence of CB receptors in the brainstem, and not those cannabinoid receptors. The endogenous cannabinoid receptors are not involved in those basic breathing circuitry. But the presence of them in the overall cortex, so like the frontal cortex, the other lobes, is going to affect cognitive function. One of the things, the presence in the hippocampus is going to disrupt that short-term memory. And then there can be some acute effects of psychosis, which is symptoms similar to schizophrenia. And that is usually after large doses are taken. There's high increased activity. And then it usually, when individuals are smoking, it doesn't happen because it's a pretty quick response. But when people take THC via food or drink, they often are like, oh, that's not that bad. But the body hasn't fully processed it yet. And so they will take more because they didn't experience those immediate effects. And then that adds up, and then you can have some pretty scary negative side effects in terms of a mild acute psychosis. And then, tolerance and dependence can develop. So this is a long-term effect, but it's going to develop in very heavy users. And there can be withdrawal symptoms. And that is because it does have some activity in the dopamine pathway. So the nucleus accumbens, the VTA to the nucleus accumbens, that reward system. And you don't need to really memorize the mechanism here, but the idea is that you do have those cannabinoid receptors. THC can bind and activate those, and then you are going to, and it's going to stop the release of GABA, and then so you aren't going to inhibit the dopamine neurons anymore. So then there's going to be that increased dopamine release. And that's, you can see that here. So GABA release inhibition, you release that inhibition by preventing that signaling or that neurotransmitter release here, which means that you're going to get more release from those dopamine neurons. And if you think of long-term cognitive function, one of the things is that there's not a lot of good data. And according to the book, the jury is still out. So any impairments are generally modest and not consistent. So we don't really know yet. But one of the things that we do know is that sometimes heavy use can lead to increased development of schizophrenia. But one of the things is it's difficult to prove causation as opposed to correlation. So maybe individuals would be more likely to have schizophrenia, or individuals who are more likely to have schizophrenia are taking or are doing THC. So that is still questionable. So if you want to put like a question mark here and a question mark here, not really defined yet. So we've looked at the mechanism of action for THC and the distribution of CB1 receptors and how THC might be acting in those areas to cause changes in behavior. And we've looked at some of the acute versus long-term effects. And now to finish up, what I'd like you to go do is access this link, and what you'll see is that there are some sections that you can choose, and then you can determine if you think that there is sufficient evidence that cannabis affects one of these functions. So if you're looking at it in this way, you're going to want to go to all the way down, scroll past this giant table, and then really giant table. And then there's a spot that is residual impact of cannabis. And if you want to control F on there, just look up residual impact of cannabis and you can go right to it. And so what you'll see is that you can read this section, so on executive function, a few paragraphs. And then the other one is attention and working memory. Again, a few paragraphs. And then overall memory, only a couple paragraphs, and then motor skills, only one paragraph, and then error monitoring, awareness, reward processing, and affective processing. So that just means emotional processing. And there's a few paragraphs on that one. So just those 5 sections. So choose from one of those, read that one section in more detail, and I want you to determine if you think we have enough evidence to say that that particular cognitive function is disrupted by cannabis use. And bring your thoughts to class. So write those down and bring your thoughts to class, and we will discuss those when we have our overall discussion during class.